No, Ashok, I have heard you that you are from Nalgonda district, right? And you are
Yes, sir.
Nalgonda district and Telangana, and you passed out in 2023 from electric and electronics, right?
Yes, sir. Yes, sir.
Yes, Ashok. You had told me that you had after your BTech you had done some 2 years of program in one of some organization.
No, sir. No, sir. Actually, 7 months, 7 months work only. After my graduation, I was preparing for the PSU examinations only. In
Okay,
the
okay,
past 7 months, I am working in the CVRD as a junior research fellowship. Yes, sir.
okay, okay.
Hmm.
Okay, Ashok. May I know for which designation you are applying in HPCL?
In electrical electronics, sir. In engineering, engineer training.
For ET through GATE 2025 or a
No,
separate
sir. It
CBT?
is a exam, separate CBT, sir. Exam through the exam.
Okay, 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 Ashok. May I know any projects or internships that you have done in your 4 years of BTech career?
Actually, yes, sir. I done my project in the BTech. In the
Yes,
is a IoT three-phase power failure monitoring.
three-phase power failure monitoring.
Yes, sir. Yes, sir.
Okay. And any internships?
No, sir. I am not doing any internship in that my BTech, but I am presently working in the CVRD as a junior research fellowship. Past 7 months
Okay.
was completed.
Okay. Ashok, can you brief about your project?
Yes, sir. Actually, my project is IoT-based three-phase power failure monitoring. That is, IoT means Internet of Things. By using Internet of Things, we can able to modify the faults at the time of faults will happens. Basically, two types of faults will be there in a power system. For fault is nothing but it is the unbalanced condition of power system network. Basically, I can say it is the two types of faults is there: open circuit faults and short circuit faults. In the short circuit fault is a symmetrical and unsymmetrical faults is there, and the unsymmetrical faults is a very it is normally happening. We don't want to predict it, but the three phase fault is happening very rarely. Very rarely, like in 100 ways, 10% is the possibility for the three phase faults, and the two three phase faults is the more severe fault. Means more dangerous faults will be there. If single line will be faults, say a single line to ground fault will happen. Only one only I naught current will be flows. If the three phase fault will be happens, three times the I naught will be flows. Means the three times more current than the normal single line current. That will be more dangerous current. That's why we normally call as a more severe fault. More severe fault.
Okay.
That's why me and my team will be working on the three phase three phase faults. That is symmetrical faults. And my work is to analyze that subject thoroughly. And in my project, in the four members are there. In my work is to analyze that subject thoroughly, and what are the requirements will be needed, that requirements I need to fulfill. That was my work in the my project, sir. This is about the sir. You are not audible, sir. Hello, sir. Sir, you are not audible, sir. Sir, not audible, sir. It's not. Sir, not audible, sir. Not getting. थोड़ा सा लो आ रहा है सर वॉल्यूम.
नहीं ఇప్పుడు వస్తుందా ఇప్పుడు క్లియర్ గా వస్తుందా
sir, now it's clear, sir.
clear but sometimes it is breaking now it is breaking, right?
Ah, yes, sir. Yes, sir.
Right, Ashoka. No, you are saying some you have used some IoT in this project. So how the IoT
Yes,
is
sir. Internet of Things. Sir.
so how the IoT is
Internet. Uh, I am not having that much idea in that, sir. But by using IoT regarding things will be handled by my friends only. I just needing the analysis of these faults, fault analysis, that kind of things only. And if it is needed, I will work on that, sir.
okay, okay, Ashok. Ashok,
Yes,
may I
sir.
know your favorite subjects in your BTech?
My favorite subjects are electrical machines, power electronics, power systems, sir.
Power systems,
Yes,
power machines. Okay, okay.
yes, sir.
Ashok, can you explain me the necessity of Ashok, can you explain me the necessity of a starter in a DC motor?
Starter. The basic purpose of the starter we need to use is to limit the starting current, sir. That's why we need to use the starters in the DC motors. Basically, 3-point starter is there, 4-point starter is there, 2-point starter is also there, sir.
No, why the starting current is high? What is the reason?
At the starting, yes, sir, yes, sir. At the starting, at the starting current will be no load, sir. If the no load, the current will be flows is more. For that case, current will be more means there is a chance of the winding will be burn out. To limit that much current, we need to place a starter in that circuit, sir.
No, if there is no load, the current will be very less, no? So you are saying in the starting, because of no load,
Yes, sir.
current will be
Actually, the
high.
full load condition. Yes, sir. Full load condition. I'm so sorry, sir.
So just take a moment of time and try to explain why the necessity of starter in DC motor. Why you need to limit the starting current? Why it will come?
Uh, to limit the starting current means at the starting heavy current will flow, sir. That's
What
why
is
we
the
need to
reason?
use
What
that.
is the reason? What is the reason of heavy starting current?
Uh, I'm sorry, sir. I'm not able to recall that, but I need to work on that, sir.
Okay, okay.
Yes, sir.
Okay, can you explain me what is the inrush current in a transformer?
Inrush current.
Hmm.
Uh, the current that will reach the peak value, sir. That is called inrush current.
No, when it will flow? What is the meaning of inrush current and when it will flow in the transformer?
Means it will the sudden change will happen in the load that way. In that time, will the inrush current will be flow, sir.
No, if there is a sudden change in the load, inrush current will not flow, right? The load component current will change.
Load component current will change. Okay, sir.
Okay. So you're saying power systems, right? In power system, what is meant by skin effect?
Skin effect. The current will present on the outside the layer of the conductor, sir. That's called a skin effect. That will happen. That will cause the power loss. That's called as skin effect, sir. That will cause the power loss.
Okay. It will in HVDC system, does it occur?
No, sir. HVDC system actually the frequency will be zero. The skin effect depends on the frequency also. So in HVDC system there is no skin effect. Yes, sir.
Zero in HVDC
That
systems
will
effect
happen,
skin
but
effect
very
is
less
zero.
compared to HVAC. Compared to HVAC, the HVDC will be less, sir. In HVDC, that is less, sir.
HVDC skin. So in HVDC skin effect presence will be there.
Uh, no, sir, it's not there. Zero, sir.
Skin effect is zero in HVDC. Sure.
Yes, sir. Yes, sir, I'm sure.
Okay. So what is the purpose of neutral grounding resistors?
To provide the path of current, sir.
For that, I can
To support us.
solidly ground the neutral, right? I'm
Actually,
asking.
solid grounded and natural ground is there is a difference, sir. We will make the solid ground means there is no natural current. Natural distance will be present in that. But the naturally grounded means there is some natural distance will be present that. By using that we can able to limit the fault current.
Neutral grounding resistor. I'm asking neutral grounding resistor. Natural, no. There is no natural. Neutral.
Neutral, yes, sir. Neutral grounding resistance only. I'm sorry.
Neutral ground resistor. Okay.
Yes, sir.
So, what do you understand by rectifier? What is a rectifier?
Rectifier is a device, sir, which will convert the bidirectional waveform into unidirectional waveform. Basically, two types of rectifiers will be there. Controlled rectifiers is there, uncontrolled rectifiers will be there. Yes, sir.
Okay.
Hmm.
So, in if I want to, what are the two types of full wave rectifiers?
One is a bridge rectifier, sir. Another one is the transformer coupled rectifier.
So, out of these two, which one is feasible?
Transformer coupled, sir.
Why? Transformer coupled,
Because
you
that
are
is
saying center tapped. Center tap
center
transformer
type.
coupled.
Yes, sir.
So it will be most used rectifier for full wave rectification.
Compared to bridge rectifier, that is better, sir.
May I know the reason?
Hello.
Yes, yes. May I know the
Yes,
reason?
sir.
May I know the reason?
Efficiency is matter. Actually, both the transform, actually, both the rectifiers having the efficiency is equal, nearly equal. Transformation utilization factor, transform utilization factor is there, sir. That's peak voltage or that kind of. I'm not remember the exact reason, sir. I'm so sorry about that. But there is a
Okay.
reason, but there is a chance.
Okay, okay, okay. No problem.
Yes, sir.
So if, now suppose Vs at an angle delta is my sending end voltage and Vr at an
Yes,
angle
sir.
0 is my receiving end voltage, okay, of a
Okay, sir.
transmission line. Now
Hmm.
can you tell me what is the equation of reactive power flow at the receiving
Reactive,
end?
receiving and reactive. There is any power factor requirement, sir?
No, I have given na Vs at an angle delta is my source voltage, Vr at an angle 0 is my receiving end
Load
voltage.
voltage. Yes, sir.
So now give me the equation for the reactive power at the receiving end.
Okay, sir. One second. EV by X into 1 minus cos delta minus V square by X. EV by X into 1 minus cos delta minus V square by X, sir. E is the sending end voltage and V is the load voltage and delta is the load angle. May I explain again, sir?
But I didn't say any E, right? I am saying V at an angle delta. Vs at an
Yes, sir.
angle
V at
delta.
an angle.
Yes, yes. Tell me.
Yes, sir. Vs at an angle delta. Or, yes, sir. Vs at an angle delta. I would say Vs into V upon X into 1 minus cos delta minus V square by X. That is the reactive power equation.
Okay. Now for the ideal transmission line,
Yes, sir.
for ideal transmission line, what will be the characteristic impedance?
Ideal transmission line characteristic impedance. So surge impedance only. We normally design the transmission like which will having the 400 ohms.
That is the natural characteristic impedance of a transmission line.
Okay. Ideal characteristic impedance will having the infinity, sir. Ideally.
Ideally, characteristic impedance is infinity for a ideal transmission line. Okay.
1 second. Power maximum.
So,
Power rating
Ashok,
maximum.
why the transformer is rated in kVA? Why not it is kW?
Because sir, the transformer having the two losses, sir. One is the copper losses, another is the core losses. Core losses depends on the reactive power, and the copper losses depends upon the active power. So for that, we can use that is a transmission line is a kVA, means kilowatt per S is equal to kVA rating. That's it. And one more thing is
So,
low that will. And one more thing is the power factor also, sir. Power factor, load power factor is not generally not constant in the every not constant in the every load. That's why we can make the power make the transformer rating as a kVA only.
your second reason, this is the primary reason. Okay.
Okay, sir.
Okay. What is the function of a commutator in a DC machine?
Function of commutator in a DC machine. The actually DC machine we can generalize normally two types. One is generator, another is a transformer, another is a motor. In the generator that will converts the AC current waveform into DC current by reversing the current direction, and the same way in the motor that will converts the DC current into AC current in the case same reversing the same current same way, sir. Vice versa, sir.
Right, sir. Okay. Just give me what are the differences between a circuit breaker and isolator in a power system?
Actually, isolator is working under the no load condition, sir. We need to work in a no load condition. Whenever the fault will be happens, and that fault will be the circuit breaker relay will be activated, then that will give the information to the circuit breaker. And one word I can say that circuit breaker working under the no load condition, sir, and the isolator working under the no load condition. That's yes, sir.
Okay, if I can use only circuit breaker in the circuit in a circuit to isolate, what is the necessity of isolator?
The only thing is we need to disconnect the circuit, sir. If the fault will be happen, if any transmission line fault will be happen, the current will be reversed at the time, and that time the circuit breaker will be open. So that's okay. But we need to repair that fault. We need to disconnect the circuit. For that case, we need to use the isolator. Isolator is nothing but a switch. I can say we
No,
normally use it in the no load
already
condition.
in circuit breaker is also a switch. Circuit breaker is open, right? Then what is the
But yes,
necessity
sir,
of isolation?
but there is a leakage current will present in the circuit, sir. So we need to remove the all the completely. We need to disconnect the completely circuit. Otherwise, the repairing person will be get damaged. That is one of the
Leakage
reasons.
current.
Yes, sir. Leakage current also present in the circuit. This thing I know whenever I was working in the substation as after my diploma, sir. And that time they will work like this only. Yes, sir.
Okay, your answer is okay, but I will explain you in the end, okay?
Okay, sir. Okay.
Okay, so as you are saying, you have done something in your after diploma, you have worked in a substation, right? Any apprenticeship like that, huh?
Yes, sir. There is a 6 months training is there, sir, after my
Training
diploma. So I for that I need to work in the 132 kV substation.
122 by 33.
Yes, sir. 132 by 33 kV substation.
Yes, can you explain me the switchgear components, SLD,
What are the
from
components?
the
Yes,
line
sir.
takeoff to load end, line takeoff. Start from the line takeoff.
Line takeoff to load end.
Yes, yes, yes. What are the components you have seen?
Lighting arrestor,
Hmm.
isolator, and the wave trap,
No,
and
no, you
the
come in sequence. Come in sequence. First, you have seen
oh,
lightning arrestor. After that,
yes, sir. Lighting arrestor. After that,
okay,
wave trap, wave trap. Then I will come to the isolator.
okay,
Then there is a circuit breakers,
circuit
CT,
breaker. Okay,
CT, and the
okay,
parallelly connected as P2,
okay.
potential transformers. Then again,
No,
again the
in
power
in
trans. There is one is the VCE voltage control device is there, sir. One capacitor like capacitor like device is there. I'm not remember.
CVT, capacity voltage transformer.
Yes, sir. Capacitor voltage transformer. That is also one of the device. This was I remember, sir. And there is another other device also there. I'm not remember exactly because in the diploma, my diploma was completed 2020, sir. There is a 5 years gap will be there.
Okay, okay. So
Yes, sir.
what will be the starting power factor of an induction motor?
Lagging only, sir. And the starting power factor induction motor is lagging.
In
Normally, the
running,
induction motor is operating under the lagging
in
conditions.
running also it will be lagging only. It will never go
Okay,
in
okay.
leading.
Let me
In
ask you a
starting,
range of induction. Range, sir.
yes, yes.
Range is 0.3, sir. 0.3 to 0.6.
In starting,
At the starting, sir.
after it is getting full at the full load,
Uh, Full load, they may 0.8, sir. 0.8 to 0.9.
why there is a drastic change in the power factor?
Because, sir, and there is a no at the starting, the induction motor, the starting power factor is. I'm not able to explain properly. Uh, can I think 1 minute, sir?
Yes, yes, yes.
Yes, sir. Thank you. Induction motor starting current and transformer starting current and no load running. Sir, to explain this, I need to go with some transformer, sir. For example, transformer is working under the no load condition. The no load current will be very less, very less. So, in that case, the power factor also very less only. That is a 0.2 to 0.3 only. That will vary. But under the it will comes under the single phase, three phase induction motor. At the starting there is no load will be happens in that induction motor, but the point is here the motor is running means current will be drawn by the current is drawn by the motor will be high. Current drawn by motor is high means power factor also high at the starting it normally compared to the transformer. The starting power factor of the induction motor is more, sir. This is the answer. Yes, sir. Sir,
Purpose of bundle conductor.
purpose of bundle conductor. Basically, I can say three reasons will be there, sir. One is the to reduce the power loss. Second one is to reduce the corona loss, and third one is we need to make the voltage profile as balance. These three conditions is the major roles to we need to use the bundle conductor. We need to transfer the more power to the large distance. Then we need to always go with the bundle conductor, sir. By using this bundle connector, we can able to reduce the inductance. For that, we need to increase the power transfer capability also. Yes, sir. Yes.
What is the use of wave trap? You are saying you have seen wave trap, right, in a substation 132
Wave trap.
kV.
Yes, sir. Yes, sir. Wave trap basic purpose is to reduce the intercommunication communication lines, sir. I can say, for example, I need to communicate with other substation with my substation means I need to use this communication. I need to use this wave trap, and there is a two purpose. One is that to reduce the intercommunication lines, and second one is that to communicate the two substations. Yes, sir. Communication purpose, I can say. I need to use the wave trap in the communication purpose. Yes, sir. Sir, not audible, sir.
Yes. Ashok, now I
Yes,
am
sir.
audible.
Yes, sir. Yes, sir.
Conclude your interview, sir. I will further discuss the points that your answers and where you need to improve. Okay.
Okay, sir. Okay.
So, starting with you are saying once you are confident with your diploma in your
Yes, sir. Actually, I cleared the two exams, sir. In HPCL, they will conduct the two exams, sir, very
yes,
recently.
yes.
One is
Hmm.
the HPCL JE post two, another one is the HPCL engineer trainee post two. I qualified the both exams, sir. I have interview in the 8th in the Visakhapatnam and the 10th in the Hyderabad.
Okay, okay, no problem. So
Yes,
if
sir.
you are much confident now, you can explain while in your introduction, you can add your diploma.
Okay, sir. I can add my diploma also.
Yes.
Yes, sir.
If you are much confident, you can add that you have done your diploma, everything.
Yes, sir.
Okay. In your notification, is there is any such thing? Mostly there will be no such thing. A diploma, 4 years of BTech is because you have done 3+3.
Yes, sir. Yes, sir.
Is in the notification any such thing? 2+4 is required.
No, sir. That is eligible, sir.
Then
Diploma plus BTech also eligible, sir.
then you
And most of my seniors are also working in the HPCL, sir. They will also
no.
eligible.
Okay, okay. Then you can explain that. And
Yes, sir.
further, you are saying you have done almost 6 months training in a 132 by 33 kV switchyard.
Yes, sir.
TS Transco from TS Transco.
Yes, sir. TS transfer. I have
So
certificate also, sir.
yes, then that might help you because
Yes, sir.
most of the time interview should be like a discussion. It should
Yes, sir.
not like be a question and answer session.
Hmm.
One person continuously asking question and a second person is giving answers. Just keep the interview like a discussion, like just what we have
Yes, sir.
discussed in last 15-20 minutes now. You just keep the
Hmm.
discussion like this only. For this, your diploma and your 6 months of your switchyard experience, those things will help you.
Okay, sir.
Any apprenticeships, any internships, through these things,
No, sir.
if no
Hmm.
problem, if you have done 6 months, you have spent 6 months after BTech in
Yes,
a
sir.
switch,
Yes, sir.
you can use that and you can first you should have a thorough idea of the SLD and every component.
Okay, sir. Okay.
Okay, and
Hmm.
most of the time you are saying I am not remembering. Try to avoid that one
Ayo. Yes, sir.
because
Okay.
that is giving a feeling. Most of the time you are saying that line and you are starting giving the answer.
Okay, sir.
Okay,
Hmm.
just ask them, sir, give me a moment.
Yes, sir. Okay.
Better you can say just, sir, give me a moment, and you try to think and you can give the answer. There is no rush.
Hmm.
Immediately after question, you are rushing to give the answer.
Okay, sir.
In that rush, you are saying, sir, I am not remembering, and with that lines, you are starting the answer.
Yes, sir. I recognize that also, sir.
Yes,
But the
okay.
problem is, for
Uh,
this case, this is the one of the reason I already cleared the GT in the previous HPCL interview. But the interview
mhm.
is gone, sir. This is the one of the main case, I guess,
So,
on
so,
that
so
time.
this is the time you should improve on that.
Yes, sir.
Okay.
Yes, sir.
These are all the things that you will make you practice for that.
Okay, sir.
Okay, just immediately after question, there is no rush to give the answer. Okay, just take a moment. If you are sure,
Hmm.
then start with the answer. If you are not sure, just ask them a moment. If
Hmm.
you don't know about the question, then you may say, "Sir, sorry, sir, I will study
Hmm.
about it.
Okay, sir.
I will read about it."
Okay, sir.
Okay, like that you can
Hmm.
give. And this DC motor starter, this is the very basic question.
Yes, sir.
In the starting, there is no back EMF inside the machine, right?
Yes, sir. Yes, sir.
Yes, this is the reason.
Ah,
This is the basic reason.
yes, sir.
So in your answer, if any interviewer is asking question, there will be some key points.
Yes, sir.
So if you are missing that key point and you are continuously giving answer,
Hmm.
that will not help.
Yes, sir.
Okay, the interviewer will wait for you to give that keyword. In the
Okay,
starting,
sir.
the back EMF inside the machine is zero. So
Yes, sir.
for this question, one of that such key line. Okay, an inrush
Okay.
current in a transformer. Inrush current will inrush the major inrush current is the second harmonic current only will happen while charging the transformer. The first time charging the transformer, the inrush current will come.
Second harmonic current.
First during the charging.
Yes, sir.
Okay, why once it is came into the load, there will be no inrush. You are saying once the load changes, the inrush currents will change, come.
Yes, sir. Yes, sir. Yes, sir. I will say that.
Okay. So what I am saying, if you are not confident, you
Hmm.
can skip it. Sir, I will study about it. I am currently not remembering. I will read about it. Like that, you can skip it. Okay.
Okay, sir.
Okay. Remaining your neutral grounding resistor is okay, but I would suggest there is a much more details about the neutral grounding resistor. Okay. It
Okay,
will
sir.
help to improve the grid stabilities also.
Stability.
Yes. It is
Power
between,
transmission stability.
yes.
Yes, sir. Okay.
So till that level, once you prepare, because all these questions, most of the components are revolving around your switch yard questions only.
Okay, sir.
Okay,
Hmm.
and in the rectifiers also,
Hmm.
the most widely used rectifier is bridge rectifier.
Appa. Okay, sir. Okay.
Okay, in center tapped rectifier, the main problem is the peak inverse voltage.
Peak inverse voltage. That is VM only, right? VM
2
or 2
VM will
VM?
come. 2 VM will come
Yes, sir.
across the diode once the diode is reverse bias.
Okay, sir. Okay.
Just study about it. Okay.
Okay, sir. Okay.
And your answer for this isolator, no, that is interesting, but that should be. I already told you that I will explain you in the end. This
Okay, sir. I
isolator,
need to
no,
transfer.
as you are saying from your experience, you are saying yes for this confidence isolator will be used. But what kind of confidence that isolator is giving? Because the contact gap between the circuit breaker contacts is in mm's, millimeter.
Yes, sir. Yes, sir. Millimeter.
Okay, in millimeters, suppose you are working in a 132 kV line or 233 kV line. So the person who
Hmm.
is working, he cannot risk his life on a millimeter gap. There will be no leakage current.
Okay, yes, sir. Okay.
The gap is only millimeters.
Hmm.
You already studied. We studied about this restriking voltage, everything. Lightning
Reverse
impulse voltages,
restriction voltage.
restraightening voltage. During
Yes,
that
sir.
time, these gap may not be sufficient
Okay.
to isolate it completely. So you have to
Hmm.
increase the gap.
Okay.
Only way that is possible to increase the more gap is through isolator. Once you have isolated means it's visible. It
Yes,
will
sir.
give
That
a
is a
visible confirmation, visible clarity and
and
confidence.
the gap also very more, sir,
Yes,
compared to separated contact.
the gap better. Then there is such even if you open the circuit breaker open, there should not be any leakage currents because
Hmm.
in circuit breaker the medium is highly dielectric in nature. Its dielectric strength is very high. So like SF6 vacuum, these kind of things we will use this. So there should not be any leakage current inside these contacts. Once
Okay.
circuit breaker is open, means circuitry is open, isolated.
Okay, sir.
For additional gap and additional working, as you are saying, yes, that is the answer. But the gap you should increase between the contacts.
Okay, sir. Okay. Yeah.
Okay. And in the starting power
Yes.
factor of the machine also,
Hmm.
starting power factor is low.
Starting power factor is low, sir.
Is low. Even in the no load
Okay.
also, in no load also, induction power machines will be operating at very low power factors. Because
Okay.
until unless you load the machine, there is no active component. Whatever the current
Yes,
is
sir.
being drawn by the machine is reactive component.
But no load also the induction motor will be working, no, sir.
Yes, yes, no load also it will work, but power factor will be poor.
Okay, sir. Under load
Because
condition, power factor is more.
because your
Okay, sir.
reactive component is fixed.
Okay.
Once you load it actively more, then your power factor
Hmm.
will improve.
Okay, sir.
Okay. And wave trap.
Wave
Once
traps.
you have explained what is wave. Once you are saying one of your component in your switchyard, that is wave trap, so you should have the idea what is the wave trap. Wave trap is the device that will
Communicate.
communication. Okay. What that
Uh,
is doing is that is blocking the high frequency signals entering into the switchyard.
okay. Okay. Okay.
Communication will happen at high frequency and the power transmission will happen at 50 Hz frequency, right?
Yes, sir.
So if any high frequency signal that is coming on the transmission line, that
Hmm.
high frequency signal will not allow it into our transformers or bus bars. We'll stop that
Okay,
signal
sir.
there only. The wave trap is a
Hmm.
huge inductor. What is the
Use-
inductive? Huge inductor. It is an inductor.
Okay, sir.
2 pi FL reactive.
Hmm.
The inductive reactance is 2 pi FL. Higher the inductance,
Yes,
higher
sir.
the inductive reactance. Higher the inductive reactance, higher the opposition.
Yes, sir.
So 2 pi FL frequency is related, right? So higher frequency signal, it will block the higher frequency signal.
Okay, sir. Okay.
That higher frequency signal will be captured by your CVT.
Uh,
And
that
that,
was
okay. And
capacity
that,
voltage.
yes, that
Yes, sir.
that will be taken, that will be captured by your CVT and it will be given to your protection. Through that signals
Mm-hmm.
we will do protection, and telephone is one of hotline communication is one of the application, but main application will be protection.
Okay, sir. Yes, sir. Production.
Okay.
Hmm.
Okay, Ashok. Most of the things I have discussed. Do you have anything to ask me? Otherwise, I will go with the next participant.
Okay, sir. It is okay, sir. Next time I will improve and I will come, sir. Sir,
Okay.
I will ask one of the general questions, sir.
Hmm.
You are also from Telangana, sir?
No, I am from Andhra, Vijayawada.
Vijayawada, sir. Okay, sir.
Hmm.
Okay. One of my colleagues is Vijayawada, sir.
Okay, Ashok.
Okay, sir. Thank you, sir.
Thank you, Ashok.
Yes. Yes, sir. Okay.